be like 1986. Each and every decimal value of the number should be extracted separately. For example, if I am given a number like 123, if I want to extract this number, this is 123. If I want to do the extraction, it should be 1, 2, 3. Or if I given number like 1881, this is the given number. Please extract all the numbers in this specific decimal. So my output should be 1. This is 1881. So my output has to be, after the execution, my output has to be 1881. Right? So how to extract all the numbers from a given decimal number? So this is how the question input value will be, and the output value has to be separated. Each and every decimal point has to be separated and extracted separately. Let us say that my input number is 1228. Output should be 1228. Right? So how do I proceed with this? So this question is very important, because with this logic you will be able to develop a lot of algorithms. Only based upon this logic you will be able to develop a lot of algorithms. So for the simplicity, let me assume that the given number is 7683. This is the given number. For simplicity, I am taking this as the given number. Right? So I need to extract each and every number to display it in the output. So if you call this number as a whole, you will be calling it like 7683, isn't it? So I do not want to do that. If I run this, if I pass this data in a particular method, my output value should be what? I should be getting all the separate numbers, 6, 8. The numbers should be separated. The whole number has to be separated with single digit. 7663. This is how I pronounce. It is not supposed to be 7683, right? So how do you build a logic for this? So this is a numbering, what we call it as, this is a simple mathematical concept. When you have a big number, so this is the big number, 7683. You want to separate 3. You want to extract this 3 separately. How can I do that? I can just divide the given number, which is 7683, divided by, I can divide it by 10. If I divide it by 10, if I find the model, if I find the remainder, so remainder is going to be 10 sevens, 70, 10 6, 60, right? 10 8, 80. So if I perform the modular operation, what I am getting here at last, remainder is 3. So I am able to extract the last number. So in other words, I can simply say, please perform the modular. This is the given number n. This is the given number n. Please perform the modular operation with 10. Right? If I do this in Java programming language, if you perform modular operation with the given number, with the perform modular operation with 10, the output will be the remainder, which is the last number. Here, in this case, output is going to be 3. So one number has been extracted successfully. The first iteration, this is just assume that this is the first iteration. In the first iteration, I am able to extract one number separately, which is 3. So this 3 stands for the first iteration. Right? Next, I have to extract what? The next number needs to be extracted is 8. So this is the next number, 8. So in order to extract 8, I have to make sure that this 8 number is the first placeholder for the particular number. What do I mean by that? This is number 8. Right? So we need to reduce this number to 3 decimal values. Now the number has 4 decimal values. So somehow we managed to get the output 3 with the 4 decimal values. Again, I need to reduce the number with 3 decimal values. I need to perform some operation where my output is going to be 768, right? So I need to perform this operation. Some operation I need to perform. I need to get 768 because we have already extracted 3. Right? I need to extract 8 now. In order to extract 8, I need to reduce this number to 3 decimal values from 4 decimal values. Right? In order to do that, what I will do, instead of modular operation, I will be just dividing this number by 10. Previously, we have did modular operation. We got remainder. Right? Do some operation where you will get quotient, which is the number is what? The number is actual number is what? 7683. When 7683 gets divided by 10, right? So again, if you see here, the quotient is going to be what? 768. Right? With the division operation, you will be reducing the decimal values. With the modular operation, you will be able to extract the last digit. Right? So with the division operation, you will be able to do what? You will be able to reduce the number of placeholders. Right? With the modular operation, you will be extracting the last digit. Extraction is happening with the modular operation. Right? If I use, let me rewrite this again. N, what is the number? 7683. 7683. Right? What I am saying is, you use modular operation in the one end and use the division operation in the other end. Right? If you divide this number, if you modular this number with 10, you will be getting what? You will be extracting the last digit, which is 3. Right? After this, if you divide this number by 10, which is 7683, if it gets divided by 10, you will be reducing the decimal placeholders. So last, the 7683 is going to be 7068. Because divided by 10, we'll consider the quotient part. Modular of the 10 is going to extract the remainder part. Right? And again, perform the modular operation here. Right? So last number, which is 8, that is going to get extracted. Right? After this, again do the division operation. So now next is 768 divided by 10. Okay. When you do 768 divided by 10, you know what happens? This 8 will be eliminated. So it is going to be 76. Right? So just let me write it here. 768 divided by 10. 776, 668. So quotient is 8. You're writing the quotient here. So this division operator is going to fetch the remainder. So it is already fetched here. Right? And again you perform the You perform the modular operation for this. What you will be extracting here? 6 will be extracted. So already we have extracted two numbers. One is this one. You see this. 3 is extracted, 8 is extracted, 6 is extracted. Now after this 6 is extracted, and again you perform the division operation here. 76 divided by 10. Now this number will get reduced to 7 because this is the quotient. And again perform modular operation here. 7 will be extracted. Right? 7 has got extracted. Right? If you perform division operation for 7 divided by 10, if the quotient is going to be 0. Right? Once you find 0, you better stop. Right? Once you find 0, once the division operator gives you the 0, even though if you perform modular operation also, it is going to be 0 itself. So it's better to stop here. Right? So if you see the output output is going to be what? 8 is extracted separately, 3 is extracted separately, 8 is extracted separately, 6 is extracted separately, 7 is extracted separately, right? If you write a simple pseudocode in the sense a basic code for this program to get executed in the Java programming language, right? If you see here, I have to use two operators. One is modular operator. So the given number needs to get modularity with the value 10, and again the number should be reduced with what? The decimal placeholder should be, a number will be reduced to 3 decimal placeholder, from 4 to 3, from 3 to 2, from 2 to 1. To reduce the placeholder, we use division. To extract the last number, we use what? Modular operation. Right? If you see, we have done 4 iterations. This is considered just one first iteration, second iteration, third iteration, fourth iteration. In each and every iteration, the number is getting reduced from 7683, 768, 76, then 7, then 0. Right? So last, for the last, the last division, the number is going to be 0. So there are, this non-zeros can be replaced as true condition. True. We can put a check for this 0, which is false. In other words, what I am trying to do is write a while loop, right? Enter the check the given number as long as it is greater than 0. This is the condition I am keeping. So a while loop is considered, and the while loop, the given number is what? 7683. Run a while loop and take the given number is 7683. As long as this number is getting reduced to 0, run this while loop. Right? So first thing is we are extracting the last number, which is, in this case, it is 3. To extract any number, what we have to do? So we have to, I'm taking a data type as integer, right? And user defined variable as extract. Extract into extract equal to number modular of 10. Right? So if for the first iteration, the extract value is going to be what? 3. Right? So if you replace this number as 7683, modular of 10, is going to obviously give me the last digit as the output, which is 3. So for the first iteration, the extract value is going to be 3. A print line system.out.println extract. So my for the first iteration, my output is going to be 3. Right? After printing 3, I need to reduce this number. So the actual number is 7683. I need to reduce this number. In order to reduce this number, what I am trying to do? I'm using number equal to number by 10. Right? The number is what? Actually 7683. 7683 by 10. So the number will be reduced to 768. In the second iteration, the 7683 is going to be what? 768. And again 768 will be compared with 0. Obviously it is greater. Again second iteration. The second iteration, the number is what? 768. 768 will be we have to perform the modularity of 10 with 768. The 768, if you perform modularity operation, this number will be extracted. So the next extract number will be 8. Again the third iteration, the next extract number will be 6. Again the fourth iteration, right? So the next extract number is going to be 7 last. So fifth iteration, what happens? This becomes 0. 0 is lesser than 0. It will come out of the loop. Right? Let me write a small Let me implement that in the Eclipse so that you will get better picture. So let me assume that the given number is what? We will take the same number, which is 7683. Right? I want to extract each and every number. As a whole, I can call this number as what? 7,800 and 683. Right? But I need to extract each and every decimal placeholder separately. Right? For that, I am taking a simple while loop. While I am checking the condition, while number, as long as the number is greater than 0, keep executing the while loop. Right? 7683 is greater than 0. As long as the number is greater than 0, keep executing the while loop. Right? So here I am going to let me take a variable as extract equal to 0. Right here, what I'm doing here, I'm saying extract. So extract equal to number modular of 10. So if I do number modular of 10, the actual number is what? 7683. The first iteration, if I do number modular of 10, what will be the extracted value? It is going to be obviously 3. It is going to give me the 3. System.out.println extract. After extracting the last digit, I cannot keep the same number here. I cannot keep the same number here. The number should be reduced to 3 decimal values. So basically, it is the number with 4 decimal values. 168, 4 placeholders. It has to be reduced to 3. In order to do that, please divide the number by 10. I can say number equal to number by 10. Right? Now number will be changed from what? From 7683 to 768. Now this will be considered as an input now, 768. Right? Keep repeating this as long as the number becomes 0. Next time it is going to be what? 76. Next time it is going to be what? 7. Next time it is going to be what? 0. So when it is 0, terminate the row. The beginning it was 7683. Right? 7683 has been reduced to 768, then 76, then 7, at last 0. The first 4 conditions is going to be true. This condition is going to be false. As long as it is true, extract the last value. First time 3 is extracted. The second iteration 8 is extracted. The third iteration 6 is extracted. The fourth iteration 7 is extracted. Right? If I just check the output, 3, 8, 6, 7. You may ask me, it is extracted. That is not my question. I mean, we have just extracted. See, the given number is 7683. Now each and every number is independent number, extracted numbers. Right? This is the logic for this code.